Hi everybody. Today we're going to work on 2.3. This is on polynomial and synthetic division. Now we're doing polynomial and synthetic division in an effort to kind of divide out our polynomials. This is like when they won't factor for us, and so we are looking for what the factors might be. So we might do division to help us find those factors or those zeros. Now as we get started doing this division, we actually need to go back and remember back in elementary school when we first learned how to do long division, because it's kind of the same process, only we're going to be doing it with polynomials. So first off, I made up this problem. I just made it up and then it worked out differently than I would have liked. Can we turn this into an 8 right here? And we'll make that be an 8. Okay, so now we're going to divide this 8,378 by 67. Okay, so 67 goes into 83 one time, and then you take your 1 times your 67 and write it down here, and then you subtract. So 13 minus 6, so that's 16, and then you bring down the 7. So 67 goes into 167 twice, and then you take your 2 times your 67, and then subtract. And then you bring down your 8, and 67 goes into 338, let's say 5 times, and then you take your 5 times your 67 and subtract. And so this one ends up with a remainder of 3. Okay, so what that really means is that to get 8,375, we would have to take our 67 and multiply it by the 125 and add any remainder to it. And that would get us the 8,375. All right, so that mentality right there, that's what we're going to do with polynomials. So to do this one, we're going to look at basically this first term right here. We're just looking at the x. And we're seeing x times what would get me this 6x cubed. So x times 6x squared would get me 6x cubed. And then once you pick that number, remember you come back and you're going to multiply it, but you're going to multiply it by this entire quantity here. So that's going to be a 6x cubed minus 12x squared. And then we subtract. I usually show subtraction by changing the signs on it, and then go back and say, all right, so that's going to drop. I've got a negative 19 and a positive 12, so that's going to be a negative 7x squared. Bring down my next number. And then you start all over. So x times what gets me negative 7x squared? It would be a negative 7x. And then I take my negative 7x times the whole quantity, x minus 2. So that would be a negative 7x squared plus 14x. And then we have to change our signs, because that's how we do the subtraction, because you got to subtract everything. So that'll turn positive, that'll go negative. Okay, and then let's combine those, cancel out, and we end up with a positive 2x. Bring down the negative 4. So start over. X times what gets you 2x? It should be a positive 2. And then take your 2 times your x minus 2, so that's a 2x minus 4. Change your signs. Oops. And everything cancels out. So this one doesn't have a remainder, so that's awesome. So then what I'm going to end up with is saying, okay, so to get this polynomial, this 6x cubed business, I would have to take an x minus 2, and I'd have to multiply it by the 6x squared minus 7x plus 2. And I don't have any remainder, so I don't have to add anything in there. All right, but even better would be if you could factor that trinomial, which we can. So even better would be an x minus 2, and then we factor this trinomial. It'd be a 2x and a 3x, and looks like a 2 and a 1, and signs are the same. And so that's the best answer, is if you can get it clear factored completely down. So here's what we've accomplished then. We had this polynomial. Now we didn't really talk about it, but normally we would try to factor this by grouping, but I can look at it and see that I'm not going to get matching parenthesis sets if I were to try to do grouping on that. And most everything we have today is not going to be able to factor by grouping. So that's what we're dealing with, things that don't factor for us. All right, so what we did is we did the long division on it, and we found the factors a different way. So once we know what the factors are, which for this problem is x minus 2, 2x minus 1, and 3x minus 2. If those are our factors, then actually we know the zeros. So the first one would get us a 0 at 2, and then the next one would be at 1/2, and the last one would be at 2/3. So by being able to get those factors, some other method than factoring, we can figure out our zeros, and this kind of takes us back to that packet that you've been working on. That means you're going to have a 0 at 2. It's just there once, so it's a cut. We're going to have a 0 at 1/2. It's going to be a cut. Factor it. Oh gosh, tiny. Sorry, that's pretty. I have to squeeze that in there. Okay, and we could graph it. It should behave like a y equals x to the third power, because we always look at the highest power on that one. And something to the third power should start low, end high. So then I could graph this thing, and it would just come down here, cut, cut, cut. All right, so that's kind of what we're doing, is tying all this together. We're actually not going to focus on the graphing today. We're really going to be working on getting these factors and turning them into zeros. So let's try this division thing. That's what we're practicing today, is the division to get to those factors. And this one's a little bit trickier. What I've got here is an issue with some missing terms. If you'll notice, I don't have an x to the 4th term. It goes straight from an x to the 5th to an x to the 3rd. So I'm missing that term. I'm also missing just a linear x term. I should have that in there. And so if you have missing terms, you have to put zeros in their place. So I'm going to rewrite this problem. You might have to write kind of small on this example. There's not a lot of space. So I'm going to write x to the 5th plus, and then just to leave a column for all my x to the 4ths, I'll put a 0 x to the 4th. And then I'll do a 2x cubed, and then my plus 3x squared, and now I need an x term, so I'll put plus 0x, and then minus 6. And we're going to do this division. I did not leave enough room there. Sorry, this is going to be kind of tight. Okay, so now I'm doing this problem, and I'm done with the problem that they gave me. So x squared times what gets you x cubed? Well, it should be, x squared times what gets you x to the 5th. Since you're adding exponents, it should be an x to the 3rd. All right, so now you take your x to the 3rd times x squared. That's x to the 5th. And then your x cubed plus 1, or times 1, is an x cubed. So you have to find the column of the x cubes. That's right here. And then you're going to subtract, so you change your signs. And then that's going to cancel out. My 0x to the 4th, I guess I didn't end up needing that column. That's all right. Remember, this is like a negative 1x cubed. So that's going to get me a positive 1x cubed. And now we start over. So x squared times what gets me x cubed? Well, that'd be a plus x. Now you may scooch that over and try to line it up with the right column. That's fine. I'm just kind of writing them next to each other. So, oh, I forgot. Remember that when you reduce, you usually bring down your next term also. But look at what's going to happen on this. I've got an x times an x squared. There's my x cubed. And then x times 1 is actually an x, so that actually needs to go over here in this column. So I really needed to also bring down my 0x so that I had all that lined up. You have to pick the column that matches your variable. Change your signs, which is your subtraction, and you get a 3x squared minus x. I'm going to go ahead and bring down the next term. All right, and then let's start over. X squared times what gets us 3x squared? Well, that should be a positive 3. So then I write 3x squared, and then I'm taking the 3 times the 1, so that's just a 3. It needs to go over here with my negative 6, because those are my like terms. Change your signs, And so those cancel. I get a negative x, negative 9. Okay, so then this is my, what we call a remainder. If it doesn't come out nice, remember, if you don't end up with a 0, then this is your remainder. And so the way that this would be written is you'd write all of this polynomial is equal to, and you write what you were dividing by, so x squared plus 1, that's called the divisor. You're going to take it times your answer, your x cubed plus x plus 3. You can look back at our example that we started with our numbers to see why I'm multiplying those. Those get multiplied, and then at the end we added our remainder. So I'd put plus, and then I do negative x minus 9. And that's what I get when I divide it out. It didn't divide out nicely, so I just kind of write what I did end up with. Now this is a pretty tedious process, but it is kind of the only method we'd have to work with factors when we're trying to divide something like this, x squared plus 1. We're going to have to do long division on that. However, there is kind of a shortcut if we are dividing this by a linear factor. This one's a quadratic. Let's try looking at a shortcut if we are dividing by a linear factor. We're going to use synthetic division. Anytime that what you're dividing by is in this format of an x minus k, where it's linear. And we're going to use synthetic division, which basically is doing the same process of long division, but you get rid of all the x's and the variable stuff, and you're just working with the numbers. And so if this is my format, x minus k, then k would be equal to a negative 1. Right here. All right, so what we do is we put that k value up here in a box, and then you list out your coefficients of your polynomials. So x squared has a coefficient of 1, 3x is a 3, and 5 is just a 5. And you're only dealing with numbers. Leave kind of a line of work, and then here's where you do the pull it down, multiply, subtract, that kind of business. So I'm going to pull down the 1. I'm going to come back and multiply by the negative 1 right here, so I'm multiplying these two numbers. That gets me a negative 1. Now notice I put in a negative 1, which is the opposite of the sign in my original right here. That takes care of the subtraction because the sign is different. So really I'm just combining here. So the 3 and the negative 1 gets me a 2. Then you take your 2 times your negative 1, which gets you negative 2. And then you combine those and get a 3. All right, so what this means is if I take this polynomial and I divide it by this linear term, this is going to be my result. Now because I did this, I took this squared one divided by a linear term. My result is always going to end up 1 power less than what I started with. So I started with a quadratic. Because I divided by an x to the first, my result is going to be an x to the first. If this was like an x to the 6th, and I divided it by this would be an x to the 5th. What this is basically just the coefficients of my result. The thing that I would normally have written up here, these are the coefficients for it. So what this is that 1x plus 2, and then this right here is my remainder. So what I end up with then is I'd say that x squared plus 3x plus 5 is equal to, and then we write the factor that we divided by. You multiply it by your result. Remember, this would be the result, the x plus 2, and then you add in your remainder. Okay, this is much faster because you lose track of all the x's and you don't get caught up in all of that. You'd still have to put in zeros for placeholders if you're missing any terms, but the synthetic division, once you get the hang of it, is quick and easy. Let's try this one. There's a little bit more going on. All right, so in this case, when I look at what is the k value in this, it's supposed to be an x minus k. I have an x minus 2. So my k value is 2. Put in my coefficients. I don't see any missing terms. All of the variable terms are there, so it's a 2, a 1, a -7, and a -6. Leave a line for work, draw your line, and here we go. You bring the first number down. Then you multiply, and we get 4. Combine, get 5. Go back and multiply by the 2. That's a 10. Combine, go back and multiply by the 2. Oh, looky there, we got a 0. Remember that that last column is always what your remainder is, so I can see here that I got a remainder of 0, which means that would have divided in there nicely, which is a good thing. Okay, so now when I look at this, I have this polynomial that I have would be equal to an x minus 2 times what I would have gotten back. And remember, what you're getting right here is what we would normally have gotten up here. It's just that you got to put your x's into it now. And since I started with a cubic right here and divided by a linear, remember that that drops your power by 1. So this is going to be a 2x squared plus 5x plus 3. And I don't have to do any addition of a remainder. Now, I do want to look to see if this would maybe factor, though, because remember, you're trying to get this totally factored. So let's see if we can't maybe factor this polynomial. So it'll be a 2x and an x. Looks like a 3 and a 1. My signs are both pluses. There we go. So we've got the factors, and thus we could figure out what the zeros are on this. All right, so let's try one more of these, of this synthetic division. This one I'd like you to try by yourself. So take a minute and pause the video and you try working through it. Let me give you a hint before you get started that you are missing your x cubed term. So when you set this up, your k value should be a -3. And when you do your coefficients, you should have a 1 for the x to the 4th. You need a 0 for the x cubed term. Then a -10 and a -2 and a 4. Now you go do the synthetic division on it. Pause the video. Okay, let's see how you did. So you should be bringing down the 1. 1 times -3, combine. -3 times -3, that's -1. Times the -3 is a +3. That gets me a 1. -3. So that one does not come out nice. I ended up with a remainder. Remember, the last one is always your remainder. So when I write what my result is, my power drops by 1, so that's an x to the 4th. So then this is an x cubed minus, oh wait, sorry, let's go back. We'll typically write our divisor first, the quantity we divided by, so it's an x plus 3. All right, then we write what we got back, and so that would be our quotient, which is going to be a 1x to the 3rd minus 3x squared minus x plus 1. And then the leftover, we add on the end. That's our remainder. Okay, now, because this did not come out nice and I ended up with a remainder, I'm not as concerned with trying to factor this result right here, try to refactor it, because in all honesty, even this was not a true factor because it didn't divide into it nicely. So I'm going to probably just leave it in that format and call it good if I'm going to have a remainder. All right, so here's a pretty slick theorem that actually is kind of convenient for us. It says here that if f of x is divided by x minus k, that's what we've been doing. We've been given a polynomial, we're dividing it by this x minus k, trying to do synthetic division if we can. But what this says is that if you do that, the remainder that you get is the same thing, would be equal to if you just did f of k. Remember what f of k means. It means that you take that number and you just plug it into the function. So like if you had f of 4, you would just plug 4 into the function, see what you get back. Well, so this is saying that if you plug that in, what you get back is the remainder. let's look at an example. This is the one we did on a previous slide. If you look back, our remainder on that was actually, on that example, was a 3. Okay, so let's look at what happens. So since the divisor was an x plus 1, that's this right here, that's your divisor, so your k value is negative 1. So what they're saying is if you can plug in negative 1 into your function, so I'm going to show some nice work here, but you're just taking this negative 1 right here and you're plugging it into this function and seeing what you get. So I'd have a negative 1, and I'm going to square it, plus a 3 times a negative 1 plus 5. This is just 1. This is going to be a negative 3. This is a positive 5, which if you add that all up, what do you know, is equal to 3. And so what you get back when you plug the number in is really the same as the remainder that you do when you do synthetic division. That's kind of nice, because remember what you're hoping for is to get a remainder of 0. So that's kind of a quick way to see if it's going to divide in nicely. If you end up with a remainder of 0 when you do your f of k, then you'll know that, oh, that's going to divide nicely. So here's an example. Note that I'm trying to help you with your homework here, that this particular problem we're doing right here is what they're asking you to do on number 47 on your homework. It says, use synthetic division to find each function value. Verify using another method. All right, so we're just kind of proving, hey, this remainder theorem really works. Because what we're going to do is we're going to take this polynomial and we'll do synthetic division with a negative 2. So if I put negative 2 in, and then list my coefficients, always be looking for zeros. I don't see any missing terms, so I think I'll just go across here. Let's do our synthetic division. Bring down the 4. That's negative 8. It's negative 10, just 20, 21, negative 42. Ooh, negative 46 is my remainder. Okay, and what we're doing is verifying it using another method. So I'm going to come over here and I'm going to do f of negative 2. That means plug negative 2 in for x. So 4 times negative 2 cubed minus 2 times negative 2 squared plus negative 2 minus 4. Okay, so to clean this up, negative 2 cubed is negative 8 times 4 would be negative 32. On this next term, negative 2 squared is 4 times negative 2. And then I have a minus 2 and I have a minus 4. And when I add that all up, that's going to be 40, 42, 40, negative 46. Okay, notice that you are supposed to be verifying, so you should be getting the same thing on both of these. If you didn't get the same thing, then you need to go back and check. One of them you did wrong. But that's the idea, is that when you evaluate the function, you should be getting the remainder. Now here's the real benefit of that remainder theorem, is that it really leads us to what we call the factor theorem, and that's really what we use. It says that if, this shouldn't be there, if f of k equals 0, so if you plug it in and you get 0 back when you plug the k value in, then that tells you there isn't going to be a remainder, and so x minus k will be a factor. Okay, so for example, if they give me some polynomial function and I do f of 7, so I plug 7 in for x, I go through it all, simplify it, and I get a 0. Okay, so that means there is a remainder of 0, meaning that it divided nicely. And so if it divided nicely, then I know that 7 is a 0 to my function. And if 7 is a 0, then I know one of the factors would be x minus 7. Okay, that's an important concept. Star that. That's an ugly star, but you know, star it. We're going to come back to that a bunch, that concept. So here, this one is help with number 52 on your homework. It says use synthetic division to show that x is a solution and use the result to factor completely. List all the zeros. Okay, so assuming that this is not going to be factored by grouping, it's not going to work out nice for that, we're going to plug 3 in, and we're going to show that it's a solution. So you put 3 into your synthetic division. There are no missing terms, so no zeros. I believe that's negative 13, so negative 39, negative 5. Oh, yep, that looks good. I got 0 for a remainder. So that's my proof. That's the first part. Show that x is a solution. Did it. Okay, it says use the result to factor it completely. Because remember that what this gets me then is 1 power less than what I started with. So this is going to be a 6x squared minus 13x minus 5. And this is my remainder.
Teachers, at this time, could you please...
All right, so we want to finish factoring this then. We know that the first factor, well, we'll come back to that. Let's go ahead and finish factoring this. So then probably going to be a 2x and a 3x. My signs are going to be different. So a negative 15 is my inner, outer is a positive 2, that factors. Okay, so I have, it was a cubic, so I should have 3 factors. And my first one is actually what I get from that 3 that they gave me. So I'd have an x minus 3 in addition to these 2 that I got after I factored. So then what would your zeros be? Okay, the first one was the one they gave me. I'd have a 3. The next one, when I set 2x minus 5 equal to 0, I'd get 5 halves. And the last one, 3x plus 1 equals to 0, I'd have a negative 1/3. So this is a great way to find those zeros, which remember, then I could go graph this thing. Not graphing today, but just understand that's where we're headed, is to being able to graph these. All right, this is our last one, and it really pulls everything together that we're talking, all these relationships. So the first part says verify the given factors. Okay, so that means going back, and if this x minus 2 is a factor, then I should be able to run 2 through synthetic division and get 0 for a remainder. That's how I'm going to verify it. Now, actually, I could just plug 2 into the function. Remember, if you plug in the k value, if you do f of k, plug it all in, see what I get back, and hopefully I get back a 0. That would be a good way to verify it. Now, the only reason that I'm not using that, because that probably would be faster, would be because of the other questions. They're going to want me to find the remaining factors. So if I just plug the 2 in, I'll get a remainder of 0, ideally, but it doesn't help me get it factored down farther. So if I'm looking to continue the factorization, I'm going to have to go ahead and do synthetic division, so I keep getting that new polynomial. All right, so here I go. I'm going to put 2 in. 2, 7, I don't see any missing terms here. You're going to have to write really little on this problem. I didn't leave you a whole lot of space. Okay, so bring down the 2. And that's 18. And that's 36, which is going to get me a 9. And that's 18. Oh, look, right there. So that's me verifying that x minus 2 is a factor. Now, the problem that I have with that right there is, remember that this power is going to reduce by 1. And so what I have left is a cubic. And I can't factor a cubic unless I'm lucky and it does grouping, and I don't think this one's going to. So what I need to do with this x plus 3 is, rather than plugging that one in and running through synthetic division back on the original and ending up with a different cubic, what I'm going to do is just continue the process on this same polynomial. Okay, so my k value would be a negative 3, so I'm going to put in a negative 3, and I'm going to do synthetic division with my result. Now, not using this column because that was my remainder. All right, so let's run this through. We get a 2, negative 6, 5, negative 15, 3, oh, there's my negative 9, so I'm going to have a remainder of 0 again. So that's what I want to verify the factor, so I verified the -3. But what's nice is that this right here was a cubic. So when I divided it, now I'm down here and I actually have a quadratic, which is nice because that's going to be more factorable for me. And then that's that remainder over there. Okay, so then let's go ahead and factor this down. So it's going to be a 2x and an x, 3 and 1, both pluses. Yep, that works. Okay, so it says find the remaining factors. Okay, that right there, those are my remaining factors. 2x plus 3 and x plus 1. In addition to the 2 that they started by giving me. Okay, what I really like though is this complete factorization. What I've got now is this quartic that I started with. It's at x to the 4th, so I should have 4 factors, or 4 zeros, and I've got all 4. So I can write this. So this is something that the book would give me, and then this is something that you would have had on your packet that we were graphing. It would have already all been factored out for you. So I have the 2 that they gave me, and I have my 2 new ones. And so this, sorry that's messy, but it's an x plus 1 is my last one. All right, so this is the complete factorization. That's what they want when they ask you for the complete factorization. All right, and if you have the complete factorization, then you also will have all of your zeros. So if you have an x minus 2, that's going to get you a 0 of 2. The x plus 3 is going to get me a -3. The 2x plus 3 would get me a -3 halves. And the x plus 1 will get me a -1. So I've got all the zeros. The last part says confirm graphically. And here's the deal. You could go to your calculator and graph this original function, and that's okay. I'd almost rather you, though, just sketch me a graph. Remember, this is what we were doing in the packet. If this is at 0, all right, we know all the zeros. There's a 0 at 2, and it's going to be that factors to the first. All of these are to the first power here, and so all of them are going to end up being cuts. So this is a cut. -3 is going to be a cut. -3 halves is a cut, and -1. Ooh, that's close. Okay. All right, now it's an x to the 4th. Whether you're looking here at the highest power or if you're counting up your exponents in the factored form, it's going to behave like a y equals x to the 4th. A y equals x to the 4th is an even, so it should start high and end high. So it looks like this. Now your calculator won't really show you that probably because you're going to have to really mess with the window. So that's why I kind of like to graph it ourselves so we get an idea of what that really is doing. All right, so that's kind of all of it tied together, and it should help you with number 60. All right, good luck.